Hello everyone, my name is Mariatta and I work as Senior Developer Relations Engineer at Google. I'm also a Python core developer. I'm here today to talk to you about unit testing and continuous integration. Unit testing is important. You should do it. If you're a developer or a software engineer, if you write code that will be used by other people, if you have code that will go into production, then you should write unit tests. You might be saying, well, I wrote the code, I ran it, I know it works. Why do I need to write tests? So running the code is basically manual testing. Writing unit tests is a way to automatically test that your code works. So let's look at this example. Say there's a function, super simple, it adds two numbers. How would you test this if you don't have unit test? You will run it. You will call the function, print it out, read the output, and verify it visually. And to say, yes, indeed, 1 plus 2 is 3, so now you know it works. So that's the manual way of testing. So programming language like Python comes with its own unit test framework for you to write automated unit tests. To begin writing tests, in your test case, you will import the unit test module, and then you will actually import the function or the code that you wrote. To test the function, you would make assertion saying that assert that the result, which is the output of the function you wrote, will be equal to the value you expect. And when you execute the test, you will see a kind of report. It would say that it ran the test and that everything is okay. So this is an example of running a test in Python where the test is passing. I'll show you an example of running tests where the test failed. So here I changed my test. So instead of saying 1 plus 2 is 3, I wrote in the test that 1 plus 2 should equal 12. So when I run the test, I see an assertion error. It says that the value I expect, 12, is not equal to the actual value returned by the function. So it failed. So I should be looking at my test and my code and figure out, was it the code that did not return expected value, or was it my expectation was wrong? So this is another reason why you want to write unit tests. You want to test that your code against various inputs and scenarios. Maybe you want to test whether the code can handle negative numbers or decimals. You can write tests for those. So writing tests is a way to find bugs in your code. As you write tests, you'll be thinking about various input scenarios, edge cases. Maybe you'll even discover a bug while you test, and therefore you can fix your code to be more reliable. Using the same example, what if we are adding two letters, A and B, instead of numbers? So what do you expect your code to do here? Should it pass? Should it return AB? Or should it fail? Like, should it raise an exception? What if one of the input is the number and the other one is a letter? What's the expectation? The code will actually raise an error. Maybe you want to go back to the code and write the logic to handle this kind of input. And if your code raises an error, you can test for that too. Say I go back to the function and now I said I only want to accept numbers. So if somebody gives me the input A and B, the code will raise an error. So now when I write the test for this, I want to ensure that the error is indeed raised if they put in a letter instead of number. And I can do this by using the assert raises. So writing tests like this help you discover issues during development before production, so it can help you improve your code. Unit tests can also work as documentation about the code. It gives information about how it works, so if somebody else is reading the code and wanted to understand what it does, they could read the test, they could see how to use it, how to call it, they could see the different test cases and understand what are the constraints and limitations of your code. So writing unit tests seems tedious. In this example, I initially wrote very few lines of code, but I ended up with 5 times more code in the form of unit tests. But this is important to do. Having unit tests will help when you want to modify or do maintenance of this code. Say, for example, there's a new Python version out and you want to know if your code will still work. You could run the test and run them against the different Python versions. You can use your test to catch deprecation warnings. So maybe you need to stop using whatever feature that's going to be deprecated in the future versions and use something else. You can add the -w flag when running unit tests to see all these warnings. And another reason why you should write unit tests is that so that you can have continuous integration as part of your process. Continuous integration is the practice of using automation to frequently integrate and merge code changes into the project. So let's talk about it. You should do continuous integration, especially if you work in a team. If you have open source code, you have more than one contributor, you should have CI as part of your process. Instead of thinking, why do I need CI? Let's think about what if you don't have CI? Merging and integrating code is actually costly. It takes time and effort. You could be introducing new bugs. It could break existing functionality. How do you decide whether to merge other people's code? You're gonna read the code. You're gonna start asking questions about the code. You wanna know, does it work? Does it do what it's supposed to do? Maybe you start asking questions about what are the constraints and limitations about the code. Does it handle exceptions? Does it cause exceptions? Does this break anything else? Is this compatible with the rest of the software? So these are the things that can be answered by having unit tests. But running other people's code is actually a complicated process. You need to first get a copy of their code into your local machine. You need to set up local environment, install your dependencies, then you run the test, wait for it to finish, and view the result. Then you have to do this all over again for the next pull request from different people. And you have to do this because you want to be certain that you're building and delivering code that meets quality standards. So in order to speed up the development cycle, you need to automate. So if you have a CI, you can have a process that will automatically grab the copy of the code changes, and this process can automatically set up the necessary environment, and it can even run the test automatically. So all you have to do now is just to ensure that the CI ran, that the test passed, so you can click that merge button confidently. And there are various ways to add CI as part of your process. There are lots of options and depending on your platform. So if you can use GitHub Actions, GitLab pipelines, and there are other third-party providers like Circle CI, Travis CI. So I'll show you an example of how to use CI using GitHub Actions. You can do this by adding a YAML file. So this is a configuration file for GitHub Actions, and it has to be added under the .github/workflows directory. The YAML file contains a set of instructions to tell the CI on how to run the tests for your project. So here's an example snippet of setting up GitHub Actions to run Python unit tests. Under the steps sections, that's where I'm telling the CI on how to run the test. I'm telling it to first install the dependencies by doing pip install, and then run the test by calling the python-m unit test, which is the same command that I use when I want to run the unit test myself. You'll also notice that there is a line that has the Python version 3.9 and 3.10. So this is where I'm telling the CI that I want the test to be run against the different Python versions. I can do more with CI. It's not just for unit tests. You can do other things. For example, if part of your measure of quality is that your code follows a certain coding style, for example, if you use Pylint or Flake 8 or Black, and you wanted to make sure that any code that gets committed complies to those standards, you can include it as part of the CI. I can also use the CI to check for coverage. In this example, I'm adding the job for running the unit test and then producing the coverage report. This test will automatically run whenever anyone make a pull request to the repository. So anyone who wants to make changes to repo, since I want to ensure a certain quality standard, I want to make sure that these checks are passing before I could merge it. Now that I know the code works, it doesn't break anything, it follows a proper code style, I can merge this confidently. So that's the introduction examples of unit testing, and there are lots of resources out there for learning more on how to write tests. There is a documentation on docs.python.org, and there are a few different tutorials. I've shared them here with you. And as you do integration testing or testing with third-party applications or systems, you may come across the concept of mocking when writing your test. So Python also comes with its own mock object library that you can use. So there are different tutorials about it as well. There is a great article from Real Python, which I found very useful. There's a talk by Lisa Roach given at PyCon a few years ago, demystifying the patch function. That's also really useful talk on this topic. Another useful testing framework is PyTest. This is a third-party library, so you need to install this separately, but it's a powerful testing framework. I do recommend that you look into this, and I use this in my personal open source projects. I use this at work as well. There's a really nice tutorial about this topic, Introduction to Unit Testing in Python with PyTest, that should get you started. And once you have unit tests and integration tests, you're eventually going to need to do end-to-end testing. So in end-to-end testing, not only you're going to test a single unit of code, not just a function, but the entire workflow from start to finish. And there is a really great tutorial from FreeCodeCamp that explains in detail about end-to-end testing. So now that you learn about unit tests and continuous integration, you know the importance of those. Do it. Write unit tests. You should have CI. Now go write unit tests. Thank you so much for listening to my talk.